All right, A.REI.3, this is video 8, solving compound inequalities. We have been working a lot with solving inequalities. We don't have any terms that are new to our journal, so don't worry about those. Compound. Compound, if you think about the word, means more than one. A couple of things that are put together. You can think of compound words, and today we're going to deal with a little bit of compound math idea. So we have compound inequalities. So looking at this graph, we're going to work in terms of x. So let's take the first one on the left. We see we have a shaded in or colored in dot, and we know that colored in dot means that we're going to have that equal sign under or as part of the inequality symbol. So what does that statement say right now in terms of the line that is going to the right from the colored in dot? So we could say that x is greater than or equal to -1. All right, looking at the right, we have another dot. So this is what makes it compound. There are two things going on. We have a open circle on 2, and that is being shaded to the left. So we have x is at the same time being less than 2. Now I didn't put an equal sign under there again because this is an open circle. All right, so now when we make it compound, we have to see if the numbers that are shaded in work for both of these inequalities at the same time. And that's the idea of this lesson. Are they going to work? Which numbers will work or which numbers are not going to work? So let's just take one. Let's work it from left to right. So since this number -1 is colored in, it should work in both of these inequalities. So is -1 greater than or equal to -1? That is a yes, okay, and that's why it's colored in. So if I work my way to the right, let's grab 0. Is 0 greater than or equal to -1? That is also a yes. So making it compound, what they're saying is since it's colored in or shaded in, it should work in both of the inequalities. So let's go back to that -1 again and check it in the second inequality. Is -1 less than 2? That is also a yes. Is 0 less than 2? That is a yes. Let's go with a +1. Let's work all 4 of these. So I'll go -1, 0, 1, and 2. So let's try that +1. Is that greater than or equal to -1? That is a yes. Is it less than 2? Of course. And let's try that last one that has an open circle on it. Is 2 greater than or equal to -1? Yes. So it satisfies the part of the inequality that it goes up to 2. However, it being an open circle, we know that it should not be part of the second one. Let's just double check that. Is 2 less than 2? That is a no. So all of the numbers that are shaded, let's call it, the -1 is colored in, it's shaded. All of the numbers up to, including their decimal notations, are going to work or be satisfied in both inequalities, except for 2, because it's not included in the answer. That's why it has the open circle. So how are we going to write this as a final answer? Well, since they are combined, we call this an AND statement. We also call it an intersection. They are intersecting each other, and it can be written in a standard notation. Let's erase all this here. All right, who are we talking about? We're talking about x. What do we know about x? I take the smallest number, -1, and I take the larger number in question, which is 2, and I think about those symbols that we talked about. We said that x on this one was greater than or equal to -1. So x is greater than or equal to, if I read it from right to left, so it's open to the x. And at the same time, we also said that x was less than 2. So x is less than 2. So this is called an and or an intersection, and we know that all of the values for x will satisfy both of these separate inequalities. Now, notice that the arrows are going apart from each other. So there aren't going to be any shared answers here. There are only going to be answers that satisfy each inequality separately. So what makes this compound is that there are two inequalities on the same number line. And we call this an OR, also known as a union. So let's take each one of these separately. Since they don't share answers, we are going to write them by themselves. So the first one says x. X what? X is going to the left, so that is less than. It's colored in, so it's equal to, and the number in question is -1. Or, again, they're not sharing answers because they didn't collide with each other. They're not going to work at the same time. Or x is going to the right, so that's greater than. It's also shaded in, so it's equal to 1. So there's no way that you can put x in the middle of the inequality like we did on the last one. See how we put the x and we had it sharing symbols? Well, they're not sharing answers, so we're not going to share the symbols with that x variable here. So we leave them separated. This is called a or a union. And you could go check values just to prove to yourself that they only work, all of these values will only work in this inequality, and all of these values will only work in the first inequality. Compound, now we're going to use all of our inverse operations that we have learned up to this point. Notice that we have x in the middle, so what can we assume if x is sitting in the middle of two inequalities? We know that this is going to be that and intersection. So how are we going to solve for x? Well, the same way we did when we were solving equations. How are you going to get rid of this 5? Well, you're going to have to subtract 5 from both sets of inequalities. So it will look like this. X plus 5 subtract 5 is less than 9 take away 5, and then the other side is 2 take away 5. This got you 0, it's gone. Bring down your symbols, and you have 4. So if you broke it into two separate inequalities to graph, what are they saying? They're saying that x falls somewhere in between -3 and +4. Again, I like to write the smaller number on the left and the larger number on the right, and then check to see if that is actually true. You have to use your brain here. You got to think, if I have a number, can it be greater than -3 and at the same time be less than 4? Well, who are those numbers? All right, so I'm actually going to go off to the side and break them into separate inequalities. So it says x is greater than, I read it right to left, x is bigger than -3. And then the other one says x is less than 4. And let's go graph and see how that looks. Greater than -3, so that's an open circle, and shading to the right, put a little arrow just to remind me that I'm going to be shading to the right. And then x is less than 4, so that's an open circle, and I know that I'm going to be shading to the left. So where are these going to collide? They're going to collide all inside of those two numbers that are in question. And again, they are sharing answers. So this is an intersection, also called and. Go check out some of these numbers. All the numbers that fall between -3 and 4, but not including. These will not work because they have open circles on them. Now, it just right in the beginning of the problem says this is an OR, so that should be an indicator to you that we have two inequalities going on at the same time. However, they're not going to be sharing any of the answers. So let's solve these two inequalities separately. Inverse operations. We need to get rid of this 1. So we subtract it from both sides. Or we're going to add 5 to both sides in the second inequality. Bring down your symbol. All right. So 3x, this is nothing, it's gone, is less than -6, or 2x is greater than 12. So we have one more step to do. Divide both sides by 3. So x is less than -2, or divide both sides by 2, or x is greater than 6. Graph it. Open circle on -2. Shading to the less than area, which are the numbers to the left. Not including -2, it won't work in its own inequality. And then the second inequality says x is greater than 6, so open circle and the numbers bigger. So as you see, the inequalities happen to be going on at the same time, except they're going in opposite directions. So we call this an or a union. I'm going to make a special note here and clear this off. Let me go back to the other one and clear this off. Here's your special note. If the x in the original problem happened to have been negative, you still have to follow that special rule from before that if your coefficient is a negative through multiplication or division, you must turn those two symbols the other way. Now this problem didn't have it, so if I made up a separate problem, I'm just making it up. So 4 is less than -2x plus 5, which is less than 9. If I did my inverse operations of the 5 to both sides, so what would we get? -1 is less than -2x, which is less than 4. Here's the note. If I had to divide all of my numbers by -2, I would have had to flip those symbols the other way at the same time. So I know that I don't have a problem on here that describes that, but I do want you to recall that special case where your coefficient is negative. You still have to flip both of those symbols. So I'm not going to solve that out. I just wanted to throw that in there for you. Now, you know, Mr. Clark down on Prodigy had a great example on one of his videos, and I highly suggest, you know, always watching other videos on YouTube. You know, Mr. Clark and I have been working hard to get you guys these lessons, so if you're ever confused by mine, always feel free to go over there. But he had a great example of a compound inequality using a compound word, and it's called teenager. You got teen and ager. So what makes up a teenager in terms of their number of age? If you're 12 years old, are you falling under the category called teenager? No. What must you be in terms of a teen? Well, you, X, must be greater than who? You must be greater than 12, right? Because you have to be 13. Or you have to be less than 20. So if you're 19, 18, 17, 16, 15, 14, or 13, I'm even going to change this. I'm going to change the first one because greater than 12 means you could be 12 and a half, but you're not a teenager yet. So I'm going to change the first one. I'm glad I rechecked that. What must you be in terms of a teenager? You must be equal to 13 or greater than. That's my mistake, okay? You must be greater than or equal to 13 or less than the age of 20. So how does that look when we put them together? X, here's my 13, my smaller number on the left, my bigger number on the right, and then we use our symbols. So X is less than 20, but it's greater than or equal. I'm reading from the X variable. X is greater than or bigger than and equal to 13. So pick a number out of there. Can 13 work? If I just put 13 in here, does it satisfy both inequalities at the same time? Well, of course, yeah. It's equal to 13 and it's also less than 20. How about 15? Would 15 work? Well, 15 is greater than 13 and it's less than 20. So I am officially a teenager. Now let's pick one out of the range. How about 20? Well, if you just turned 20 years old, it only satisfies the first inequality because you're greater than 13. But if you are 20 years old, can you be less than 20? So this is a no. Sorry, a little messy there. And it does not satisfy it. So, you could go graph that on the bottom. I'd probably use intervals, looking at my number line, intervals of 5, I would say, to be able to get all those options on your number line. Go check out his video. He's got great explanations when it comes to compound inequalities. Okay, in your journal, I'd like you to write a few sentences on what you learned from the video, and if you had any questions. Remember, there was that negative issue with flipping the symbols, and the last one here with the compound inequalities. That is the meaning behind all of this, why we are putting both of these on the same number line. So any questions, write them down, and I'll see you in class.